So till now we have done the area of triangle. Okay. So what was area of triangle? Just have a look. Brief look over the area of triangle formula. Okay. The ratio of the area of two. It means that if the two triangles are similar, then the ratio of the area of two triangle is equal to the ratio of the corresponding sides. Okay. Both the triangles corresponding sides. Okay. For example,
Ma'am, I'm not getting the triangle chapter clearly.
From the starting only, Shazan.
Starting I had down in BPT theorem.
Okay. If you just ignore for BPT theorem right now, just for now, then can you tell me that what you are having any issue in area of similar triangles? You understood that how two triangles are similar?
Yes, ma'am. All the sides, if they are similar.
All the sides are in the same ratio, not
yes.
Okay, they are in the same ratio, and the angles are equal. Then the triangles are similar. Congruent and similarity is different. Congruent means everything will be equal. Your sides will be equal. Okay, but I am talking about similarity. In similarity, your size may vary. Okay, but this looks will be similar. Okay, so here if in area of triangle you'll see the ratio of the area of two similar triangles. That means if two triangles are similar, for similarity there are three criteria. Now so now for similarity there are three criteria. SSS, that is side. If all the three sides are in ratio, then all the angles will be equal and both the triangles will be similar. Okay. AA criteria, if all the three angles of both the triangles are equal, that means their sides will be in the ratio and both the triangles are similar. Now SAS, if one angle is equal to the means if one angle of both the triangles are equal and the two sides that are containing that angle are in the ratio, then the two triangles are similar. These are the three criteria. Okay, through these three criteria you're going to prove that two triangles are similar or not. Okay, you're going to check. So if the two triangles are similar, it is already given to you that it is similar, or you after some steps you prove that two triangles are similar, and it is asking what will be the ratio of the areas. The ratio of the areas will be equal to the ratio of the corresponding corresponding side. The square of the ratio of the corresponding side. Okay. With green mark, you can see area of triangle APC by area of triangle PQR will be equal to AB by PQ, one of the sides ratio, square is equal to AC by PR is equal to BC by QR. Okay. Any doubt in this area of similar triangle theorem? Rudronia, Safia, Shazan? Anybody has any doubt in this area of similar triangles?
No, ma'am.
Are you sure now, Shazan? For BPT,
just one second.
Have you gone through all the handouts?
No, not all of them.
All the handouts are there. Okay. H1 is related to your BPT and the converse of BPT. H2 is related to the second topic, that is your similarity of triangle. H3 is related to the area of triangle, and H4 is for Pythagoras Theorem, that I will cover.
Ma'am, actually I don't have my own device and my mother don't give that phone. That is that.
So can't you use it on laptop?
On laptop, I think I'm not able. I'll not be able to see.
Okay, I will confirm those, Sava ma'am, and tell you that I think you can in laptop also you can open the app. Okay, from there you can do.
Yeah, I can open that.
I can understand that your mother will also be needing her mobile. It is every time it is not possible to give mobile. Okay, so you can do in your laptop also. Okay, and handouts are there. All the notes that I am from where I'm teaching, all the notes that you see that I create here, same notes are available there. Okay, once you will go through everybody thoroughly there, all the step by step, I don't think you will face problem. And still, if you're facing problem, then I'm here. Okay. Now let's see the question based on the area of the triangle. Now question number 1 in the example number 2, in the given figure, if DE is parallel to BC. Now if DE is parallel to BC is given, okay, that means this condition is given. You have to find the ratio of the triangle. The two triangles here whose ratio we need to find out is ADE, the smaller one, the tip triangle, okay, and the the second one is not a triangle. It is the you can see trapezium, DECB. Okay, you need to find out the ratio of the DECB. Okay, now first of all, if you see here, how can you find out the ratio of both the figures? Okay, so for triangle, we can find out the ratio of the smaller triangle in comparison of the bigger triangle. Okay, and if you come to know what is the ratio of the smaller triangle to bigger triangle, then you can subtract this area, the bigger triangle here. If you see, okay, if you see here the bigger triangle ABC, in the ABC you will find out the area of ABC, and then you also find out the area of ADE in the bigger triangle ABC minus area of ABC minus area of ADE. will be equal to area of DEBC. Okay, so first we are going to find out the ratio of both these triangles. Okay, now how can we find out the ratio of both the triangles? For that we need the sides. Okay, but before that we need to prove that both the triangles are similar, because if both the triangles are similar, then only we can apply the similar triangle area theorem. Okay, now for that, to prove the both the triangles similar, here you can see DE is parallel to BC. Okay, if DE is parallel to BC, that means angle ADE. Here I will draw AC. Just ABC, and one line is here DE. This. Okay, now this is parallel to BC. That means if this is parallel to BC, so this angle will be equal to this angle, corresponding angle, and this angle will be equal to this angle, corresponding angle, and angle A is common in both the triangle. Okay, so now with AAA criteria, both the triangles, triangle ADE is similar to triangle ABC. Okay, now since you have already proved both the triangles are similar to each other from AA criteria, now we can find the ratio of the areas. Now therefore area of triangle AGE by area of triangle ABC will be equal to what? One of the side you can choose. Okay, now only this side value is given to you, that is 6 centimeter, and this side to 12 centimeter. Now we are going to choose the same side. Okay, that is DE by BC whole square. Okay, now this will be equal to 6 by 12 whole square, which will be equal to 1 by 2 whole square. Okay, so now we have got the ratio of the triangle, that is AR, triangle AGE by area of triangle ABC is equal to 1 by 4. Okay, 1:4. So that means if area of triangle ADE is equal to X, then area of triangle ABC will be equal to 4x. Okay, it is 1:4 ratio. So if you will assume that, because this is the ratio, everybody, why I'm taking x and 4x, because we don't know the exact area, we have find out the ratio. So if it is ratio is 1:4, that means if area of triangle AD, the smaller triangle area is x, that means the area of the bigger triangle will be 4x. Okay, now if we have to find out the area of the trapezium, this DEBC. Okay, DEBC. This will be equal to area of triangle ABC, the bigger triangle, minus area of triangle ADE. Yes, ADE. So that will be equal to 4x minus x, that will be equal to 3x. Okay, so now if you find the ratio of both this area of ADE, whose ratio you need to find out? ADE by area of DEBC will be equal to x by 3x. That will be 1 by 3. The ratio
I have just one doubt. How did you take 4x?
For how did I do that? Will explain. Okay, listen, Shazan. Do we know the area of the triangle?
No.
No. We know that we have calculated ratio. Ratio of this triangle is 1 by 4. We have calculated what? Ratio of both the areas of the triangle. Now since we know the ratio, we don't know the exact area, so I am assuming that if the area of the triangle ADE is x, okay, it is 1:4. So if the triangle of if the area of triangle ADE is x, that means the area of triangle is 4x. Okay, okay. Now similarly, see, we have to find out area of this portion DEBC. Now this area will be equal to the, if you find out the area of the bigger triangle and you minus the area of the smaller triangle, then you will get this area of DEBC. That only I have done. Okay, I have subtracted it. So area of bigger triangle is 4x and area of smaller triangle is x. So I got the area of DEBC at 3x. Now if you find the ratio, it will be 1:3. Okay, Safia, Rudronia, any doubt? Okay, now in this question, now everybody try to do this question. Okay, I'll just copy it. Okay, now everybody try to do this question. Okay, this is question number 3, example number 3. Okay, now here the diagonals of a trapezium PQRS intersect each other at the point O. Okay, they're intersecting at O. Now it is telling that PQ is parallel to RS. Obviously PQ is parallel to RS, then you can prove that alternate angles are equal. Okay, now you have to prove that okay, not prove, PQ is equal to 3RS. Okay, PQ is equal to 3RS. Find the ratio of the area of triangle POQ and ROS. Now this triangle you need to find out. One is SROS, no? One is this triangle and one is this bigger triangle. You need to find out the area of both the triangle, a ratio of both the triangle. Okay. Now anybody can tell me how you are going to find out the ratio? For ratio, first step what will be? That you need to prove that both the triangles are congruent. Now, how can you prove that both these triangles are congruent? Shazan, can you tell me how you can prove this?
O and R both are common and both the triangles.
I think sides value are not given. So basically, we are going to use which of that criteria? A criteria?
A criteria.
Now, can you tell me all the three angles? How can you prove that all the three angles are equal? Is angle SOR is equal to POQ?
Yes.
Yes. Why? Opposite angles? Yeah. Because both the lines are parallel, okay,
Yes.
and they're intersecting. That means they are alternative angles, vertically opposite angles, okay. They both are vertically opposite, and vertically opposite angles are equal. So that means angle SOR is equal to angle POQ, okay. Now two more angles. Now two more angles in the triangle are this, and the smaller one is this, okay, and in the bigger one are this, okay. Now how can you say that? See, SR is parallel to PQ. Okay, and these lines are intersecting. Okay, that means this angle will be equal to this angle. Okay, and this angle, both are same color. This angle will be equal to this angle. The vertically opposite angles. Okay, they both are vertically opposite angle. If you see in this figure, okay, they are vertically opposite angle. Vertically opposite angles are always equal because SR is parallel to PQ. If SR is not parallel to PQ, then you cannot say that. Okay, but here they are vertically opposite angles. So therefore, SRP is equal to angle SRO. SRO is equal to angle OPQ, and angle RSO is equal to angle OQP. Okay. Now for this, we know that they are vertically opposite angles. Vertically opposite angle, and for both this, it is alternate angles. Okay, and why we are able to do this? Because PQ is parallel to RS. Okay, now from AA criteria, all the three angles are equal. Now from AA criteria, triangle, what are the triangles? POQ is similar to triangle ROS. Now if both the triangles are similar, then we can find the ratio from the POQ area upon area of triangle ROS will be equal to PQ RS ratio of the area of POQ by ROS. POQ by ROS. Okay, so that means it will be PQ by RS whole square. Now it is given to you in the question that PQ is equal to 3RS. Okay, so PQ is equal to 3RS means 3RS by RS whole square. That will give you 3 by 1 whole square, which is equal to 9 by 1. So 9 by 1 is the ratio. Understood? Anybody, any doubt?
No, ma'am, I understood.
Okay. Now this is same like we did previous question. Okay. So I'm not going to do this. Okay. Now here, question example number 5. Prove that the area of the equilateral triangle described on the side of an isosceles right angle triangle is half the area of the equilateral triangle described on its hypotenuse. Okay. So many describes are here. Okay. Now when you are reading this question, first of all, you need to draw the diagram. Okay. Now it is written first. See, prove that the, let me copy. Okay. Now prove that the area of the equilateral triangle. Now it is saying you that you have to prove that the area of the equilateral triangle described on the side of an isosceles triangle. Okay. So first we need what? An equilateral triangle. Equilateral triangle described on the side of an isosceles triangle, right angle triangle. Okay, right angle triangle. So one is a right angle triangle. Okay. Okay. So this is somewhat this type of a figure. Understood? Okay. These sides are equal, okay, and this and this and this are equal, okay. If it is a question, half the area of the equilateral triangle described on it hypotenuse. Okay. Now it is given that let me mark it as okay. Now this is a right angle triangle. Okay. Now if given is that triangle ABC, in which angle ABC is equal to 90 degree, okay, because it is a right angle triangle, okay, and AB is equal to BC, okay, AB is equal to BC because it's an isosceles type, okay. And what else it is given? That triangle ABD, if you see the figure, triangle ABD and triangle ACE, both the two triangles that are drawn and extended on this right angle triangle, okay, this triangle, that is AD, okay, angle, triangle ABD and triangle ACE, okay, these two triangles are equilateral triangles. Equilateral triangles means all the three sides will be equal. That's why I have marked this, okay. 2 means these three sides are equal and here 1, okay. So all these three sides are equal, okay. They're equilateral triangle. Now we need to prove that half the area of the equilateral triangle describe on its hypotenuse, okay. That means area of triangle ABD is equal to half area of triangle CAE, okay. ABD is equal to half the area of triangle CAE. Now how can we prove that? Okay, now since AB is equal to BC, AB, okay, this side AB is equal to BC, it's given AB is equal to BC. You can assume it to any value or you can just interchange. So CA value will be what? CA, since it is a right angle triangle, this triangle is a right angle triangle. So, and you know that AB is equal to BC. Now value of AC will be what? It will be root AB square plus AC square, okay. So if its value is A, so A square plus, if you are assuming it as A, okay, so it will be A square plus.
Blue color is not visible actually.
Okay, if blue color is not visible, I will I'll take orange. Okay. Now what happened? Okay, now why it is just turning again and again? I know this. Okay, so CA will be equal to root, or you can write first like this, that CA square is equal from Pythagoras theorem. Okay, so CA square is equal to AB square plus BC square. Now the CA value will be equal to AB square plus BC square. Now if you are assuming it as A, and any value you can assume because we don't know the exact value, so we can write as A square plus A square, which is equal to 2A square. Okay, now 2A square will be equal to what? A root 2. Okay, so this will be the value of your.
Ma'am, can I ask a question?
Yeah.
Ma'am, I already got A square plus A square. Just
see, if you see this triangle, Shazan, then AB is equal to BC is given. Okay, AB is equal to BC. Okay, and see here I have written AB is equal to BC is equal to A. This I am assuming because both the sides are equal. You can assume
okay, I understand.
A, B, C, D, any value, and this is not known. This is like a variable. It's better that you can assume like X here. Okay, if you assume X, it will not give you a confusion because X are generally taken as variable. Okay, see. Okay, now it will be. I have written A, so you must be thinking that it is a constant value. It's not a constant, it is a variable I have assumed. Okay, so it will be X square and X. Okay, now we have got the value of ACA in the form of X. Okay, X root 2. Okay, now if you see the triangle here, where's the figure? Now if you see the triangle ABD, okay, ABD, the extended one on the left hand side, okay, and CAE, the extended one on the right hand side, that proper one, the pink one. This triangle and this triangle. If you see this, each angle is 60 degree as their equilateral triangle, okay, because both the triangles are equilateral triangle. So their angle, all the three angles will give you as 180 degree. Some will be 180 degree. So each angle will be equal to 60 degree. Okay. So that means both the triangles will be similar. Okay. So triangle ABD will be similar to angle CAE from AAA criteria. Both are equilateral triangle. Therefore, each angle to 60 degree. Okay, because both are equilateral triangles, so all the three angles will be equal to 60 degree. Therefore, from AA criteria, these extended triangle, from this right angle triangle, the two extended triangles will be similar to each other. Okay, now we'll see the ratio. Okay, now if we'll find out the ratio of the triangle ABD by area of the triangle CAE. It will be equal to what? One of its sides, that is AB by CE square, which will be equal to AB. AB will be x, and x root 2 whole square. So it will be x square, 2x square. So it will be 1 by 2. Okay. So ratio will be 1:2. Understood? It was asking you the ratio only. Yes, no? Prove that the area of the equilateral triangle described on the side of an isosceles right angle triangle is half the area of the equilateral triangle. Okay, it asks you to prove that it is half the area of the equilateral triangle. Okay, so everybody got this question? Okay, first we have proved that both the triangles are similar. Once we have proved similar, and we come to know what will be the ratio of this side AB by CE, the value of AB by CE. Okay, AB by CE. Okay, and we have find out the value of AC here. Where it is. Yeah, okay. And we have assumed the value of BC here. Now, we are finishing this area of triangle here only. Okay. Now, we'll move to the Pythagoras theorem of triangle. Okay. It's too black. Wait, just a minute. It's showing me here. Then what happened? Just a minute. Summation. Anybody, any doubt till now?
No, ma'am, till now.
Let's see. Okay, I'm not able to see that. Okay, now it's visible. Okay, so topic 4 is your Pythagoras theorem and its converse. Okay, I think you know everybody that what is Pythagoras theorem. Okay, Pythagoras theorem is what? That if it is this is a triangle, right angle triangle, ABC, then AC, and this the AC square is equal to AB square plus BC square. Okay, now this Pythagoras theorem is also there. Now today we'll learn that how this condition is proved. Okay, so the theorem we will study, and the converse of Pythagoras theorem also will cover, and one more theorem. Okay, now let's start with theorem 1, that if a perpendicular is drawn from the vertex diagram. Okay, now if a perpendicular is drawn from the vertex of a right angle triangle to the hypotenuse. Just a minute, the diagram is missing here, I think, from notes. Wait a minute. Okay, I will attach the diagram, or I'll draw it here. Okay, here only I will draw. I'll attach it afterwards. I'm drawing for everybody. Okay, now. Okay. This is the diagram here. Okay. Now, if a perpendicular is drawn. Now, if a perpendicular is drawn from the vertex of a right angle triangle, now it is telling you that first of all, if a perpendicular is drawn from the vertex of a right angle triangle, the first thing that you need is a right angle triangle. Okay, this right angle triangle. Here you can see a right angle triangle is there, ABC. Now, perpendicular is drawn from the vertex of a right angle. Now, one perpendicular is drawn from the right angle triangle. Now from here I have drawn a vertex, okay, of a right angle triangle to the hypotenuse. Then triangles on both sides of are sides of the perpendicular similar to the whole triangle and to each other. Okay, now this triangle, in this triangle you can see in triangle ABC how many triangles are there. Actually we constructed 3 triangles. When we drawn a perpendicular from B to the hypotenuse AC, then we have divided the bigger triangle into 2, and we already have one bigger triangle also. So total of 3 triangles we have. How many triangles we have? 1, 2, 3. Now what are the triangles? First triangle is that the bigger one, ABC. Now the next triangle is ABD, and one more triangle is CDB. Okay, so there are almost 3 triangles here. Okay, now we have to prove that the 2 smaller triangles are similar to the bigger triangle, and the 2 smaller triangles are similar to each other also. Okay, now how we are going to prove? Let's see. Okay, now here you can see triangle ADB. 3 conditions are here. Triangle ADB is similar to triangle ABC. The one smaller triangle is similar to the bigger one, and another BDC is similar to triangle ABC, and third, both the smaller one are similar to each other. Now, if you see the first one, ADB, ADB on this triangle, ADB, okay, and the bigger triangle. If you see both these triangle, now can anybody tell me that for similarity, how can you prove that all the three angles are equal to all the three angles of the bigger one? Angle A is common in both the triangles, okay, the bigger one and this ADE, okay. So one angle we have got, that is angle A. Now the next two angles, angle ADB will be equal to angle B because they both will be 90 degree, because since this line is perpendicular, so this angle will be 90 degree, okay. And the remaining angle, the left angle is ABD will be equal to angle C because both will be equal to 180 degree minus, not 180 degree, 90 minus angle A, it will be 90
minus theta.
Yeah, because one angle is already 90. So from 180 will minus 90, you'll get only 90. So from 90 minus angle A, this angle, I can say this angle will be equal to this angle because both angle will be represented as 90 minus angle A. If you see the smaller triangle, this angle is 90 and angle A is common in both. So this angle ABD will also be equal to 90 minus angle A. And if you see the bigger triangle, angle B is 90, angle A is common. So this angle C will also be equal to 90 minus angle A. So from AAA criteria, both the triangles are similar. Yeah.
How will C be equal to 90 minus angle A?
Okay. Now I will show you differently. Now one triangle is this. Okay. A, D, B. Okay. I'm drawing separately both the triangles. Okay. A, B, C. Okay. Now A is common in both, and this is 90 degree. This is 90 degree. Right, Sophia?
Yes.
Okay. Now the sum of all the three angles, angle A, angle B, angle D, in smaller one, if you see, it will be equal to 180 degree because sum of all the three angles of a triangle is equal to 180 degree. Okay. The same will apply in the bigger triangle also. Angle A plus angle B plus angle C will be equal to 180 degree. Yes. Now angle B is equal to 90 degree and angle A is already there. Okay. Now here angle D will be equal to 90 degree. So angle A plus angle B is equal to 180 degree minus 90 degree, which will be equal to 90 degree. Okay. So here angle B will be equal to 90 minus angle A. And here this I will not write B because this will be very confusing. Here you can write A, B, C. Oh no, A, B, D. A, B, D. Okay. And here again this is 90 degree, so angle C will be equal to 90 minus angle A. So both the values are same. Angle ABD is also equal to 90 degree minus angle A, and angle C is also equal to 90 degree minus A, and A is common both. Okay, so both the values are same or not, Sophia? Sophia?
Yes, ma'am.
Okay, so have you understood why both the angles are equal? Because the value are same. Okay, so from angle AAA, from criteria AAA, both the triangles are similar. Now, in the same way, we are going to prove the another small triangle to big triangle, BCD. In BCD and ABC, again, you have angle, this angle. This angle is 90 degree. Blue will not be much visible, but different color for that. Okay, this angle is 90 degree and angle B is 90 degree. Okay, and here angle C is common. Okay, in bigger one and the small one, angle C is common, and angle BAC will be equal to angle BAC because both will be equal to 90 degree minus C. So again, from AA criteria, these two triangles will be similar. Okay. Now we have to prove both the smaller triangle. Now how can you prove both the smaller triangles are similar? Anybody? How can you prove both the smaller triangles are similar? That is the easiest. If I say A is similar to B, and
Ma'am, I think that's the ratio of both the triangles.
No, see, Shailan, answer me this. That if I tell you that if A is similar to B and B is similar to C, then you can say this or not, that A is similar to C?
Yes, ma'am.
So that is the same thing. We have already proved that this smaller triangle, the upper smaller triangle, ABD is similar to triangle ABC. Okay? Not you have to mention the angle same. See, if I'm taking triangle ABC, then it will be similar to triangle ADB. Okay, because angle B and angle D are 90 degree. Okay, angle A is common. Okay, so triangle ABC is similar to triangle ADB. We have proved it. Okay, and similarly, we have proved that triangle ABC is similar to triangle. This smaller one will be ABC is similar to triangle BBC. Okay, so since both the triangles are similar, okay, both them ABC is only there. So therefore, triangle ADB will be similar to triangle BDC. Okay, understood? Any doubt in this theorem 1? Anybody, any doubt? Rudoniel, Safiya, Shazan? Okay, so shall I move forward? Now comes the Pythagoras theorem. Okay, now what does the Pythagoras theorem say? Pythagoras theorem, in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. Okay, now how we are going to prove this? Okay, now we are given that there's a right angle triangle ABC. Okay, and we have to prove that the hypotenuse, okay, hypotenuse square will be equal to the other two sides square sum. Okay, now for proving this, we are actually drawing BD perpendicular to AC. Okay, a simple construction we are doing, that is, blue is not visible. No? This color is visible?
Yes.
Okay, it's fine. So we have, in Pythagoras theorem, we are doing a simple construction. Okay, that is, that we are drawing BD perpendicular to AC. Okay, BD perpendicular to AC, that means if it is perpendicular, so this will be 90 degree. Okay, so from theorem 1, in fact, from theorem 1, what you can say, that triangle ADB is similar to triangle ABC and triangle BDC is similar to triangle ABC. Yes, this is a right
Yes,
angle triangle. And that only we have proved here. From right angle triangle, if you draw perpendicular to the hypotenuse, then both the triangles are similar and both the triangles are similar to the bigger one also. Okay, so from this, from theorem 1, okay, we got that triangle ADB is similar to triangle ABC and triangle BDC is similar to triangle ABC. You can take it as 1 and 2. Okay, now from equation first, since triangle ADB is similar to, now we already know that if two triangles are similar from BPT, okay, if two triangles are similar, then the ratio will be equal. Okay, two triangles are similar, that is this one. Okay, so we have got that AD is equal to AD by AD by AB. AD by AB will be equal to AB by AC. Okay, now if you see that, so AD dot AC is equal to AB square. Okay, now from equation second, since these two triangles are similar, this is from equation first. These two triangles are similar, their ratio will also be same. Okay, so we are choosing the sides which will help you to prove Pythagoras theorem. Okay, BC by AC. Okay, now again this will apply that BC square is equal to DC. Okay, I'm writing the same format. So here what you will get, AC multiplied by DC is equal to BC square, BC whole square. Okay, now if you will see both the equations here, if you see both the equations, this third one and the fourth one. Okay, if you see both the equations and if you are going to add both the equations, okay, now I am adding equation third and fourth. Okay, if you will add both the equation, what you will get, AD AC plus DC AC is equal to AB square plus BC square. Okay, AD dot AC plus AC plus DC. Okay, now on simplifying, what you will get, AC is common in both. I am taking AC as common and it will left with AD plus DC. Okay, AD plus DC. Now AD plus DC will be equal to what?
Ma'am, AD plus DC equals to AB square plus BC square.
AD plus DC. AD plus DC will be equal to what? AC square. AC?
Yes.
Okay.
Oh, yes.
Okay. From the figure. Okay, so from the figure we have got AD plus DC is equal to AC. So AC multiplied by AC will give you AC square. Okay. Now any doubt?
No, ma'am.
So this was about Pythagoras theorem, and now our class is almost over. Next class we will cover up the converse of Pythagoras theorem and the converse of Pythagoras theorem and the examples on these topics. Okay, understood? Now before coming to next class, just go through the handouts. Okay, you will find in your app. Okay, in the app and inside the handout in H4 section you will find this Pythagoras theorem. Go through what I have taught in the Pythagoras theorem and what is coming also. Okay, so that whatever doubt you are feeling that okay why it is done, so that doubt can be clear very nicely. Okay, you will also know where you didn't understood, and when I will be explaining that, if you understood in one time only, that's very good, and if still you feel like there's a doubt, so you can ask and clear it. Okay, everybody, so I'm closing here.